Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. Information about it can be found at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, you can go to smarturl.it/help-ISU actuary. This is the problem for today for exam MFE. Consider the following three-period binomial tree model for a stock that pays dividends continuously at a rate proportional to its price. The length of each period is 1 year, the continuously compounded risk-free interest rate is 10%, and the continuous dividend yield on the stock is 6%. And you were given a binomial tree of prices of the stock. Calculate the price of a 3-year at the money American put option on the stock. Note that the price of the stock at time 0 is 300, so that's the exercise price of the option because the option is at the money. We begin by calculating the risk-neutral probability of an up move, and in this model, that's P star, that probability is equal to e to the r minus delta minus d divided by u minus d. But of course, S sub 0 times d is the value of the stock in the down move. S sub 0 times u is the value of the stock in the up move. So this can be written also as the ratio of S sub 0 times e to the r minus delta minus S sub d over S sub u minus S sub d. And now we have all these values given in the problem. The starting price is 300, after down move is 210, after up move is 375. So when we plug in all these values, we get the probability to be approximately 0.610217652, and 1 minus that, the probability of a down move, is approximately 0.389782348. And then based on the exercise price, we calculate the payoffs of exercising the option at various nodes. So at time 0, of course, the price of a stock is 300. The exercise price of the put that we're studying is 300, so the payoff is 0. It's the payoff of immediate exercise of the option. It is an American option, so it can be exercised at any time. Of course, we can only consider that at the times when we have the price, so at all of the nodes of that tree that we're analyzing. At time 1, the up node payoff is 0, at down node payoff is 300 minus 210, or 90. At time 2, the up payoff is 0, and up down payoff is 300 minus 262.50, so 3750. And down node payoff is 300 minus 147, so 153. At time 3, the up node payoff is 0. Up down node payoff is 0. Up down node payoff is 300 minus 183.75, which is 116.25. And down node payoff is 300 minus 102.90, which is 197.10. Because we're dealing with an American option, we have to compare at each node whether it's better to keep the option or exercise it, and we do this backwards from time 3. Time 3 values are settled by their payoffs because there are no future cash flows. At time 2, up expected present value of future payoffs is 0 compared to the exercise value of 0, so the value is 0 either way. But in general, we pick the one that is bigger because that's the one that will be chosen by a rational investor. Now, up-down node expected present value of future payoff is probability of going up times 0 divided by e to the 0.10. And the down node payoff is the probability of going down divided by e to the 0.10. The present value factor is 1 over e to the 0.10. Times 116.25, and that's approximately 41.000172 compared to exercise value of 0. So the option will not be exercised. Down node expected present value of future payoffs is approximately 102.87723 based on the probability of going up and down and discount factor of 1 over e to the 0.10, and the two payoffs that we calculated. While the exercise value is 153, so it is optimal to exercise the option at this node. Then at time 1, the up node expected present value of future payoffs is, well, the standard calculation again, probabilities times the the present value factor, which is 1 over e to the 0.10, times the payoffs in the up and down move. So it ends up being 14.460336 compared to exercise value of 0, so the option will not be exercised. And down node expected present value of future payoffs is the probability weighted average of the present values of 41.00172 and present value of 153. That is approximately 76.59967, and the exercise value is 90, so it is optimal to exercise the option at this node. And then at time 0, the exercise value is 0, but the expected present value of future payoffs is the probability of 0.610217652 of the up move divided by e to the 0.10 to get the present value times the value of the option in the up node, which was 14.460336, plus the probability of going down divided by e to the 0.10 times 90, which was the value of the option in the down node. And that is calculated to be approximately 39.726311, and that's almost exactly answer choice D, which is 39.73, and this completes the solution of the problem. Please remember, this is copyrighted material. The problem itself comes from the Society of Actuaries, and it's reproduced with permission. The solution is mine. Well, good luck in your studies and good luck on the test.